right? Here in the 15th question, photograph shows a musical instrument called harp. When a harp string is plucked, transverse waves travel along the string, forming a standing wave. State what is meant by a transverse wave, right? So I hope you remember the definition. What oscillations or vibrations are perpendicular to the direction of energy transfer or direction of wave travel, right? So this is the sorry, actually, right here. Uh, this is the oscillations, and they are perpendicular to the direction of energy travel or direction of uh, wave travel, right? So I have to write that. So oscillations or vibrations are perpendicular to the direction of one direction of energy transfer or wave travel. Transfer or wave, right? Right. Diagram represents one string of the harp. The string is fixed at both ends. The string made to vibrate at its lowest frequency. Add to the diagram, show the stationary wave on the string. Should label any nodes and antinodes. I hope you remember the diagram, right? Will vibrate like this in the lowest speed, right? Here it will vibrate this, right? And what are the nodes and what are the antinodes, right? Here I will draw it so we can easily recognize nodes and antinodes, right? Here we have a node, and here also we have a node, and here we have, we call an antinode, right? Or you can mark it over here, right? At the mid of the uh, string, you'll get an antinode, right? And here for this one it is 1 mark, and for the this one it is also it is 2 marks, right? Shape of the wave you will get 1 mark, and for the antinodes and nodes you will get 1 mark. Okay. In the C, one string produces sound with a frequency of 196 hertz. The wavelength of the wave on the string is 0.72 meter. The tension in the string is 41 newton. This string breaks and needs replacing with a new string. The table shows the mass of the 4 new strings A, B, C, and D. Each new string has a length of 1.5 meters. Right here they have given that the new string is cut to the same length as the broken string and is placed under the same tension. Deduce which new string A, B, C, or D should be used to replace the broken string. Right. So how can we do this one? Here they have given the mass of string, and they have mentioned what the length of the string. So right, if you know what we call the mass per unit length, then you can multiply it from the length, then you can have the mass. But how can we find this one? I hope you remember the equation what P equals, right, T over mu square root of T over mu, right? This is the velocity of a string, like the above diagram, right? Okay, then how can we find V, right? To find mu, we have to find T because they have given T, so we don't need to worry about that. How can we find V, right? V is equal to F times lambda. So by using this one, you can find V, then you can find mu, then you can find M. Let's go along these steps, right? First you have to find V, and V is equal to F lambda, which means 196 hertz, right, times what? 0.72 meters, right? 0.72 meters, 0.72 meters, right? And then if you calculate this one, what you will get here is 141 meters per second, 41 meters per second. Then to calculate mu, what should we do, right? The V equals square root of T over mu. Then you have to make the square of P, then the is equal to T over mu. So if you subject mu, that is equal to T over P square, right? Okay, now we are going to calculate the mu, right? It is the tension they have given, it is 41 newtons, and now we know the V, right? It is 141 meters per second, so we have to take the square of that value, 141 meters per second, right? So if you calculate this one, what you will get over here is 2.06 times 10 to the power minus 3 kilograms per meter. Right, now you know the mu, right? According to the previous explanation, I told you, if you know the mu, mass per unit length, then you can calculate mass by multiplying it from the length here. So if it is 2.06 times 10 to the power minus 3 kilograms per meter. So if you know the length is they have given, it is 1.5 meters, 1.5 meters. So if you simplify this one, what you will get over here is 3.09 times 10 to the power 3 kilograms, right? If you make it into grams, right, so it will be 3.09 grams, right? So what would be the string? So you can clearly see should be string B. Why? Right? It is 3.1, right? The mass is nearly equal to 3.09, right? Okay, now we have to mention your what? Conclusion, right? Uh, so, right, right, mass of the string, oh, make it into two significant figures. Yes, string, right, is 3.1 grams. So, B, right? So, here they have allocated 4 marks for this question. So, how can, right? Here, the 1 mark is given to for the use of P equals F lambda. Then 1 mark is given for use of this one, right? And calculating the mu, right? Okay. Then 1 mark for this whole thing. And to use this m equals mu times L, you will get another mark, 1. And for the final answer and the conclusion, you will get 1 mark, right? So that's how 4 marks are given to your answer, right?